So now I want to talk about measures of variation and what that means, because we just talked about measures of center, but what is variation? So variation describes how widely data are spread about the center of a data set. So for example, this normal curve right here is low variation because the data is not very spread out. This has moderate and this has high variation, right? The data values are really spread out. There's always variation in data, and we need to measure how much a set varies, and we do that using range and standard deviation. So standard deviation, is the most common measure because it provides a numerical measure of the variation. Note the standard deviation is always positive or zero. It will only be zero if all the data values are the same. And the value of a standard deviation is smaller when there is less deviation and greater when there is more deviation. We're going to be working with this for a little bit. So let's consider the following two sets of quiz scores for 9 students. Which set has the greater range? Well, remember, range is smallest to largest. So the range of quiz 1 is 10 minus 1, which is 9. And the range of quiz 2 has 10 minus 2, which is 8. So quiz 1 definitely has the greater range, but which set has greater variation or greater spread of its data? Well, that's going to be quiz 2. Standard deviation is our main way that we as statisticians like to describe variation. How to calculate the standard deviation, what you do is first thing we want to do is for standard deviation is we're taking the square root of the sums of our data values minus our sample mean squared, so that none of them are negative, right, over our sample size minus 1. And I'm going to go through an example of how to do this by hand, but this is something you can do in Excel, or I put a link to StatDisk on our Canvas course. You don't have to do this by hand, but we're going to walk through it. So here's the formula for standard deviation. You do not need to memorize this. S is the conventional symbol for standard deviation of a sample. If you're looking at the standard deviation of a population, that's when it's sigma, which is lowercase sigma, which is a Greek letter. Remember that X bar is the average. X is each specific data value, N is the total number of data values in our sample. So what do we want to do? First, we find the deviations. That means we take our data value minus the mean for every single data value. The ones above the mean are going to be positive. The ones below the mean are going to be negative. That's why we have to take the squares to get rid of all the negatives. Next, we take the sum of all the squares. That's what this summation symbol means. And we divide that by the total number of data values minus 1. And then we take the square root of this fraction. Quotient also means ratio, fraction, just so we get all of our terminology straight. And that's how we calculate the standard deviation. I have an example worked out for you step by step. If you want to go through it, it is in the PowerPoint. So you can see what we're doing, see how we subtracted our data value. We got our data values, we subtracted the means. We then squared all the means to get all positive numbers. We added all those together. This is the sum of our x minus x bars squared. Then we divide that by our total number of data values, take the square root, and we find the standard deviation. We are not going to do this. Okay, feel free to try this one on your own. I'll post the answer in the PowerPoint. But I want us to focus on the fact that we can use standard deviation to tell us more about a data set, and that we're going to be able to solve these things in Excel. So one thing I want us to do, though, is quick consider these two data sets, set A and set B. And set A and set B have some pretty interesting properties. Both have the same mean, median, mode, mid-range, and that's a lot in common. Yet, the sets are clearly different. Look at their spread. So on a range from 42 to 100, B is really spread out, while A is pretty concentrated. A has less variation than B, and let me prove to you why. So, A scores are clustered together. B scores are more spread apart. And to truly distinguish between these two sets, then, we're going to need something other than measure of center. That's why measures of variation are so important. We need to look at the scores that measure the variation in the data. So we're going to calculate their range and their standard deviation. So the range of A is 77 minus 65, which is 12. The range of B is 100 minus 42, which is 58. So we can already kind of see that A is more concentrated and has less variation than B. Variance is the first step before we take standard deviation. Variance is the standard deviation squared is our variance. And this isn't as common as standard deviation because we do take the square root of both these to get to our equation for standard deviation. Notice that Greek letters represent population parameters and Roman letters represent sample statistics. So if we know the variance, we can get the standard deviation. So if our variance is 9, the standard deviation is 3. So let's calculate set A's variance and standard deviation. So we take our sample minus the mean, square it, add them all up, divide by n minus 1. That gives us a variance of 22.72. We take the square root, that gives us 4.77. That's our standard deviation. And here's our standard deviation squared. Now for set B, again, we take our mean minus our data value. So in this case, it would be 71.5 minus 42, which gives us a negative, 42 minus 71.5. That gives us a negative 29.5. We square it to get them all positive. We take the sum, we divide by the total number of our sample size, minus 1. That gives us a variance, which when we take the square root, gives us a standard deviation of 18.2. So let's compare these two sets. So A has a variance of 22.72 and a standard deviation of 4.7, while B has a standard deviation of 18.2. We could already tell from the range that B was more spread out than A, but now we have a way to quantify it. So here's again the formula for standard deviation of a population. You do not have to memorize this. What's different is instead of dividing by n minus 1, you divide by n, which is the size of the population. Instead of x bar, you're also subtracting mu, which is our sample mean, our population mean. What's nice is we don't always compute this by hand. The answer is that we can do this in Excel. You can use this in Google spreadsheets, OneNote spreadsheets. These are the equations you're going to need in order to calculate those. In some of these, you could do on a calculator if you wanted to take the time, but you could be working with a really large data set, and then it's most effective to use some sort of computing software like Excel.